Hello, my mystery seekers. I'm Greg with my blog History Mystery. Today, we're diving into the dramatic cosmic crime scene, where the universe is the victim. There's a hole in the universe, so vast, it shouldn't exist. A billion light-year void in the constellation. Eridanus is colder, emptier, and stranger than physics allows. Could it be a scar from a collision with another universe? The answer might rewrite reality itself. As always, I've got my brilliant co-pilot, Brian, to help me piece it all together. Brian, take the stage.
Thanks for setting the stage, Greg. Now, while you kick back, I'll handle the heavy lifting because we're about to unlock a secret buried in time. A story the world has overlooked for over 1,000 years. In the serene, bone-chilling vacuum of cosmic nowhere, precisely 1.5 million kilometers from Earth, nestled like a forgotten snow globe in the gravitational sweet spot known as Lagrange point L2, spins a golden eye in the sky. This is the Planck telescope, a marvel of European cosmic ambition, a silent sentinel coated in gold leaf, not for vanity, but because even in the frigid void, photons of ancient light deserve a worthy mirror. Back in 2013, Planck's mission seemed as prosaic as intergalactic accounting: gather the faintest whispers of the Big Bang's afterglow and stitch together a thermal baby photo of the infant universe. Astronomers expected perfection, a smooth, symmetrical, cosmic soufflé of warmth, evenly baked across 13.8 billion years of expansion. They braced for harmony, not horror. But when the data finally trickled into server rooms in Paris, what greeted them wasn't celestial lullaby, it was a scream. Instead of the anticipated gentle mottling of orange and yellow temperature ripples, a monstrous blue bruise stained the southern hemisphere of the cosmic map, lurking in the direction of the constellation Eridanus like a cosmic black eye. At first, scientists chuckled it off. Surely a calibration hiccup, maybe a cosmic dust bunny caught in the lens, the universe's version of a stray eyelash on a selfie. Yet each rescan, each recalibration only deepened the dread. The bruise remained. It wasn't a glitch, it was a verdict. To grasp why this patch of anomalous chill sends shivers down the spines of even the most stoic astrophysicists, you must understand the universe's baseline body temperature. The cosmic microwave background, the ambient glow of creation itself, hovers at a crisp 2.725 Kelvin, give or take a few decimal ghosts. Think of it as the universe's eternal room temperature, the thermal echo of a fire that burned out eons ago. According to the standard model of cosmology, this temperature should be as uniform across the sky as freshly sifted flour, deviations measured not in degrees, but in microkelvins, the cosmic equivalent of noticing your latte is 0.007 C too cold. Yet in Eridanus, the temperature dips by a staggering, to physicists anyway, 70 microkelvins. To the layperson, that's less heat than your breath on a winter window. To an astrophysicist, it's like finding an iceberg floating in the middle of the Sahara, a violation of cosmic etiquette so egregious it makes the laws of physics blush. The standard cosmological model, that grand textbook of universal evolution from primordial soup to TikTok, begins to wheeze under the weight of this anomaly. Statistically speaking, the odds of such a cold region arising by random fluctuation are less than 1.85%. In other words, mathematically, this spot shouldn't exist. But there it hangs, occupying a massive swath of our southern sky, gazing back at us with the icy indifference of a fact that refuses to be ignored, like your cat judging you for eating cereal straight from the box at 3 a.m. And let's not kid ourselves. Calling it the cold spot is a masterclass in understatement, the cosmic equivalent of describing a black hole as a bit of a sinkhole. This isn't just chilly, it's a fundamental defect in the fabric of space-time. A place where the universe seems to have forgotten to turn on the heat. If the cosmos expanded uniformly like a balloon, inflating in a quiet room, why does this one patch look as though someone pressed a frozen steak against it? This isn't statistical noise, this is a clue, a cosmic breadcrumb, leading back to an event of unimaginable violence in the first breaths of time. Nature, as any good dramatist knows, abhors both a vacuum and an unexplained chill. In thermodynamics, cold isn't just the absence of heat, it's often the absence of stuff. No energy, likely no matter. We've been taught that galaxies are scattered across the universe like raisins in a well-mixed loaf of bread. But the cold spot whispers a darker tale. Someone took a cosmic ice cream scoop the size of 1 billion light-years and carved out a chunk of reality itself. For years, skeptics scoured every byte of Planck's data, hunting for earthly excuses, dust on the lens, software bugs, even the ghost of a disgruntled grad student haunting the servers. But the cold spot remained, stubborn as a parking ticket, its blue hue radiating a quiet, mocking certainty. By 2025, the jig was up. We weren't dealing with a measurement error. We were staring into the mouth of the largest single structure ever discovered. A supervoid so vast it mocks our understanding of cosmic architecture, a void so profound it throws the sacred Copernican principle that the universe looks roughly the same everywhere into the shredder. Imagine, if you will, a hole in space 1.8 billion light-years across. Light, that speed demon of the cosmos racing at 300,000 kilometers per second, would need nearly 2 billion years just to cross it. That's not a pothole. That's a continent-sized crater in the cheese of reality. In a universe supposedly as homogeneous as well-stirred pancake batter, finding a cavity the size of a football nestled inside your loaf isn't just improbable, it's physics-defying. Yet here it is, real and relentless, a silent scream in the thermal map of creation. This is no ordinary void. It's a cosmic quarantine zone, where galaxies should cluster in dense filaments of the cosmic web. The Eridanus supervoid shows only a sterile emptiness, like opening a library and finding every book gone, leaving only dust motes dancing in shafts of indifferent light. Supercomputers analyzing galaxy density reports confirm the horror. Matter here isn't just thin, it's virtually extinct. You could drift for billions of years through this region and see fewer galaxies than you'd spot with the naked eye from your backyard on a clear night. It's the ultimate ghost town, where even the ghosts have packed up and left. And now, the real kicker. If you extrapolate based on the average density of the universe, this supervoid should contain about 10,000 Milky Way-sized galaxies. 10,000 stellar archipelagos, each hosting hundreds of billions of stars and trillions of planets, entire ecosystems of potential life, light and poetry, simply missing. Observations reveal a matter deficit of roughly 30%, which sounds tame until you realize it translates to over 1,230 fully formed galaxies that have vanished from the cosmic census. Poof, gone. Not hiding behind a nebula, not cloaked in dark matter, just absent as if someone hit delete on a chunk of reality. Try to fathom that loss. We can't even see 1,030 galaxies with the naked eye from Earth, but here, in one lonely patch of sky, lies the ghost of an entire metropolis of worlds that never were. The missing mass? A number so large it has 45 zeros. That's enough raw material to build millions of civilizations, entire mythologies, and yes, probably a few alien versions of reality TV. But it's just gone, vanished. And physics, that stickler for bookkeeping, demands an answer. Where did it go? Skeptics, bless their methodical hearts, proposed alternatives. Maybe it's dust, a cosmic curtain hiding a bustling galactic neighborhood. But radio telescopes, those X-ray specks of astronomy, see right through dust. And in Eridanus, silence. Not even the whisper of cold hydrogen gas, the raw clay of galaxy formation. What's more, the void lies far from the dusty plane of our own Milky Way, so it's not us blocking the view. Perhaps dark matter, that invisible cosmic scaffolding, is hiding there. But gravitational lensing, the bending of light by mass, shows no distortion. The void has no hidden weight. It's not just empty of light, it's empty of gravity itself. This isn't a room with the lights off. It's a room with no walls, no floor, no ceiling, just pure, unadulterated nothingness. Here's where things get truly mind-bending. Gravity, for all its reputation, is a slowpoke sculptor. To carve out a void this size through natural gravitational evolution would take, about 80 billion years. That's nearly 6 times older than the universe itself. Finding the Eridanus supervoid is like walking into a garden planted yesterday and finding a fully grown redwood. It shouldn't be possible, and yet it is. So if gravity didn't dig this hole, who did? Enter the photon. Imagine a single particle of light, born 380,000 years after the Big Bang, minding its own business, cruising through the cosmos at light speed. Then it hits the edge of the Eridanus void. Now, in a normal universe, a void would be like a hill. The photon climbs in, loses a bit of energy, then regains it zipping back down the other side. But our universe isn't static. It's stretching thanks to dark energy. So by the time our weary photon reaches the far edge of the void, the downhill slope has vanished. The universe expanded while it was napping. Result? The photon limps out colder and redder than when it entered, a phenomenon called the integrated Sachs-Wolf effect. But here's the rub. When scientists crunched the numbers, this effect could only account for about 20% of the observed chill. That leaves 80% of the cold spot unexplained, a cosmic cold case with most of the evidence missing. It's as if your bank account was drained and the bank tells you, yeah, we withdrew 20%, the other 80%, magic probably. This energy theft implies something far stranger than mere emptiness. The void isn't passive. It's actively siphoning energy from light itself, which means it's not just a hole, it's a cosmic vacuum cleaner with a PhD in thermodynamics. And it gets personal. Turns out this supervoid isn't just chilling photons, it's shoving us around too. Our entire local group of galaxies, including the Milky Way and Andromeda, is rocketing through space at a dizzying 630 kilometers per second. For decades we blamed a great attractor in the direction of the Norma cluster, a gravitational heavyweight pulling us in. But the math never quite added up until 2017, when astronomers realized we're not just being pulled, we're being pushed from behind by the Eridanus void. Yes, you read that right. Emptiness can push. In the grand theater of gravity, dense regions pull, but underdense regions effectively repel. The supervoid acts like a cosmic whoopee cushion of repulsion, blasting us away with silent, invisible force. They even gave it a name, the dipole repeller. Think of space-time as a trampoline. Galaxies are bowling balls, creating dips. The supervoid, it's the flat, taut area where nothing sits. So everything rolls away from it. We're not falling toward the great attractor. We're fleeing the cold spot like it's a cosmic fart. Now armed with temperature anomalies, missing galaxies, and unexplained repulsive forces, cosmologists faced a choice. Keep patching the standard model like a leaky boat, or consider the unthinkable. What if this scar was inflicted from outside our universe? This is where theoretical physics trades its lab coat for a spacesuit and dives headfirst into the multiverse. The radical idea? Our universe isn't a solitary snow globe, it's one bubble in an infinite cosmic foam of universes, each with its own laws of physics. And in the first fraction of a second after our Big Bang, while inflation stretched our universe faster than light, we might have bumped into a neighboring bubble universe. Picture 2 soap bubbles drifting in zero gravity. They touch. At the point of contact, tension builds, then a merger or a recoil. In cosmic terms, such a collision would unleash energy so vast it could blow matter clean out of the contact zone, creating a void before galaxies even had time to form. The supervoid isn't empty because matter left. It's empty because matter was never allowed to arrive. And here's the kicker. This theory predicted a specific signature, a cold core surrounded by a slightly warmer ring of compressed matter, like a bruise with a red halo. When Planck's data was re-examined, bingo, that's exactly what they saw. But the plot thickens. This cold spot doesn't exist in isolation. It lies along a mysterious axis, dubbed with delightful melodrama the axis of evil, where the large-scale structure of the universe seems oddly aligned, violating the principle that the cosmos should look the same in all directions. Even more unsettling? This axis suspiciously lines up with the plane of Earth's orbit around the Sun. Is it a coincidence, a calibration error, or a cosmic wink suggesting we're not as insignificant as we thought? Skeptics cried foul, "Look elsewhere effect," they shouted, arguing that in a vast data set, weird patterns will always emerge by chance. But then came 2022. New analyses revealed the cold spot isn't a fuzzy blob, it's a precise ring. Random fluctuations don't make circles. Circles imply a center, a point of impact. Then, in 2024, quasar surveys, those lighthouses of the distant cosmos, confirmed a dearth of active galaxies deep within the void. Not just on the surface, a tunnel of nothingness stretching billions of light years into the dark. The statistical fluke defense crumbled. The void was real, three-dimensional, and profoundly unnatural. Now, here's the existential kicker. This supervoid isn't static. It's growing. Thanks to dark energy, the mysterious force accelerating cosmic expansion, the void is stretching faster than the space around it, like a cancerous cell dividing. In simulations projecting 100 billion years into the future, the Eridanus void merges with neighboring emptinesses, forming a sea of absolute darkness. Galaxies become lonely islands, their light unable to bridge the ever-widening gulfs. Future civilizations peering into the night sky would see only blackness, concluding they are utterly alone in a dead universe. Cosmology itself would become impossible. They'd never know they were born in the golden age of stars. So what lies beyond the void? If it is truly a scar from a collision with another universe, then on the other side might reside a reality where gravity repels, light crawls slower than sound, and time flows backward on Tuesdays. The cold spot isn't a door, but it might be a fingerprint pressed against the window of our cosmic aquarium by something vast, alien, and utterly indifferent. Yet for all its terror, the cold spot is also a triumph. Here we are, carbon-based life forms on a speck of rock orbiting an average star, armed with nothing but math, mirrors, and stubborn curiosity, staring into the abyss and saying, "I see you." We measured the weight of nothing. We mapped the shape of absence. We dared to ask why the universe has a bruise, and in doing so glimpsed the possibility that our cosmos is but one stanza in an infinite cosmic poem. The cold spot teaches us that the universe isn't obligated to be tidy, fair, or comprehensible. It simply is. And in its vast, chilling indifference lies a strange kind of beauty, the beauty of a mystery so grand it humbles us, yet so tangible it invites us to keep looking, keep probing, keep dreaming. So the next time you gaze up at the stars, remember, somewhere in the southern sky, past the twinkling lights, lies a hole so big it swallows galaxies, so cold it chills the echo of creation, and so mysterious it might just be the universe winking at us from beyond the veil. We may never cross it, but we can marvel at it, and in that act of wonder, we touch the infinite. After all, in a cosmos this strange, the only sane response is to lean in, pour a drink, and say, "Well, that's a new one." The cold spot didn't just steal galaxies, it stole our cosmic complacency. And for that, oddly, we should thank it. Because in the chilling silence of Eridanus, we didn't just find emptiness. We found a question so vast it could fill 1,000 lifetimes and a universe far wilder, weirder, and more wondrous than we ever dared imagine. Can you please give me 2-3 options of the brief description of this text that I can use for my YouTube post?
And that's a wrap for today. We hope this presentation was both helpful and inspiring. and that it sparked your curiosity about universe. If you enjoyed what you heard, be sure to check out more of our podcast. We've got plenty more celestial wisdom coming your way. Got a topic you are dying to explore? Let us know. It'll be my pleasure to dive into it in a future video and answer all your burning questions. Till then, stay curious, stay cosmic, and live your best, most aligned life.
Thank you.